I drive a 1993 Toyota Corolla wagon, which I will drive until my husband dies because I can get him in the front and I can get his wheelchair in the back. So it has to last until he passes. I use natural gas in the house. Fortunately, all of my electric is wind, so I was able to do that and felt good about it. So I'm not against the idea of oil and gas drilling, but I'm against stupid. And I have to tell you that much of what I've seen since 2011 here in Ohio, we did the first 2 wells at the end of 2010, has been stupid. And one of the first big stupid things is that we are drilling and fracking in the black shales. Now, why is that stupid? Well, the reason that it's stupid is because for the last 160 years, all of the oil and gas that we have pulled out of the earth was made in those black shales and then rose higher to trap formations. So if you're a farmer, you do not eat your seed corn. But what we've done is we're drilling our seed corn. And furthermore, because we're fracking the most highly hydrocarbon-enriched portions of the shale, we're fracking and eating our hybrid seed corn. And on top of that, we're putting down biocides, which who knows what that's going to do to all those little biological creatures down there that are helping to make all of that oil and gas. Furthermore, we're only getting about 8% of it out. So that means 92% of it's staying in the ground. And we have absolutely no idea what's going to happen to the rest of it and whether it will ever be able to make oil and gas again. So if we do this really wrong, we may have 15, 20 years worth of oil and gas and then no more forever. And nobody's looking at that. But we should be. I mean, that's a waste of a natural resource, let alone a taxing stream and a royalty stream. So I hope this shows, because I know we've got light and I tried to bump up the colors, why the current concern in Ohio about the waste streams. Well, Ohio has paid for state and local governments by taxing or tipping fees or whatever out-of-state waste streams for at least the last 20 years. We fund soil and water conservation districts with the state match from construction and demolition debris landfills. What an awful thing to do to soil and water districts. That's where their money comes from. When Kasich was elected, several of us looked at each other and said, what's the next waste stream we can get? Because it's going to have to be something we can grab quickly because we are going to continue this process. And shale gas drilling is a huge, big new waste stream. It's not addressed by the surrounding states, by and large. And it was seen as a new and easily captured revenue source by Ohio's administration. We wanted not only all of ours, we wanted everybody else's too, because those tipping fees keep our government going. But Ohio does not have magic geology that can swallow all waste without repercussions. Somehow, magically, we crossed the state line. West Virginia has very few injection wells. Pennsylvania has even fewer. Magically, Ohio is just fine. No, I'm sorry. The geology is virtually the same either side of the Ohio River. We just have a state government that approves. Now, how did we get here? Well, in 1986, the Federal Emergency Planning Community Right to Know Act, EPRA, was passed. This predates fracking. Fracking gets started in the early 90s. But that's an important act, and I'm sure Jim will talk about it a little bit later. Teresa Mills loves this act. Also, and I think it's 86, but I may not be right on that date, the Resource Conservation and Recovery Act decided not to include oil and gas. And in that process, took them out of the cradle-to-grave tracking. Now, at the time, I don't remember being upset about the oil and gas, but they took the coal out as well. And we were in the process of doing the chemistry on every coal seam in every coal township in Ohio. And we did it for all the heavy metals and all the radioactive metals too, both for the coal and for the ash. And we knew that that stuff was not safe to work with. Brine or production water was given this Hail Mary pass. We know it's filled with salts, it's BTEX, it's heavy and radioactive metals, but there's no federal oversight at all. But Pennsylvania, very interestingly, requires that their brine trucks carry a hazardous waste sign while they're traveling through Pennsylvania. And as soon as they get to Ohio, they take the sign off. We as a state could pass the same legislation. We could require them to have a hazardous waste sign. We could require them to be considered hazardous waste, if they clearly are chemically. And that would give us some powers that we don't have now, especially in terms of protecting public water supplies. So, who makes all the decisions on oil and gas in Ohio? This is really important because we were bought, sold, packaged, and wrapped with a ribbon long before the first well ever went in. In 2001, as a rider on the budget bill, the oil and gas industry was removed from the Emergency Planning Community Right to Know Ohio program through CERC. They don't have to report to the State Emergency Response Commission. And the reason that they don't have to is because this bill stripped them of that responsibility. They're only supposed to report to DNR. Local controls for permitting and zoning and all of that came off in 2004. That bill was an ALEC-written bill, and it was passed by the House. It was a Tammany House bill, and I'm sure that Jim O'Reilly may talk about him a little bit more. All the power transferred to DNR in multiple bills over the following years. It was all completely done by 2010. The end of 2010, we get our first 2 wells. And it was the Ohio House, Senate, and the budget bills passed by Republican control and industry funded. And we even know how much money the industry gave and to whom. And we've known that all along. And it was really cheap. They sold out cheap. So, what are the major potential contaminants from the production? You know, we know about what's going on the pads, we know they're drilling, but what comes out and what do you have to deal with? Well, you've got the shale cuttings. They're full of heavy and radioactive metals, they're full of salts, hydrocarbon sulfates. The drilling muds are secret formulas. Nobody really knows what's in the drilling muds. The fracking fluids have hundreds of possible chemicals and no 2 mixes from well to well. And those are also secret formulas. We have flowback fluids or production brines. Those are highly saline waters, very highly saline waters. And they're full of heavy and radioactive metals, including radium, which is water soluble, and BTEXs. And the brine that comes out of the black shale is significantly different than the brine that comes out of a sandstone or a limestone formation. Because as the oil and gas moves up, the heavy metals and the radioactive metals stay in the shale. They don't come with the oil and gas. We also have releases of gases, both methanes and the wet gases and radon, and oil. And radon is the second highest cause of lung cancer in the United States after smoking. Now, geologists at least, and geological engineers and a bunch of other people have known that the black shales were radioactive for a long, long time. We didn't just learn this in 2011. This is a 1960 U.S. Geological Survey publication looking at oil yield and uranium content of black shales. The Chattanooga Shale in Tennessee, which is why Oak Ridge is where it is one of the sources of uranium for the Manhattan Project. So this isn't new, folks. And anybody who tells you they didn't know about it, either were not paying attention at all or they're lying through their teeth. Black shales are radioactive in two ways, and you need to understand this is a natural process. This is what black shales do. They're radioactive from their parent source rocks. If you're the Devonian Marcellus, you're getting weathering of clay minerals out of the Appalachian uplifts. If you're the Silurian Utica, which is older, that's earlier mountain building and the Canadian Shield. But the other thing that happens is the bioaccumulation. Because all these little unicellular critters were swimming around in these anaerobic, swampy black seas. And their carbon content is in the shale itself. So these shales are really big, dirty, old, activated carbon filtration systems. It's like putting a Brita filter on your faucet. And everything that's a heavy metal or a radioactive metal globs out of that filter and the lighter stuff comes through. And it works really well, except that they've been there for 300 million years and nobody changed the filter. So they're just doing what they're supposed to do. The older the rock and the higher the carbon content, the more the radiation, all sources being equal. And how they know where to frack is they put a gamma logger down the hole, and where they get the highest level of radiation, that's the zone they frack. So they're not pulling the least radioactive material out. They're pulling the highest radioactive material out. NORM, naturally occurring radioactive material, T-norm, technically enhanced. What do we test for in Ohio? Well, there are 4 national definitions. Ohio uses the Conference of Radiation Control Program Directors. 1990, this predates horizontal wells. It is the least restrictive, and Ohio amended it even further. The US EPA, the National Academy of Science, and ANSI, which is an engineering national standards group, all add to that norm the potential for increased exposure once it comes to the surface. And that makes the entire waste stream, from the cuttings to the brine to everything, T-norm and subject to testing. 5 picocuries per gram is the US EPA cleanup standard, and 5 picocuries per liter is the US EPA drinking water MCL for radium. And that would apply to the whole waste stream. 5. A good Marcellus brine has got somewhere between 15 and 20,000 picocuries per liter. The half-life of radium-226 is 1,500 years. It takes a long time to get down to 5, unless you are lucky enough to dilute. In 2013, in the budget bill, we decided to rewrite our T-norm. And we limited it to even a smaller amount. We limited it to the filter socks at the injection wells, the sludges, and the pipe scale. And we updated the Ohio Revised Code. But we never wrote new rules. And by never writing new rules, we never updated the Ohio Administrative Code. So there are no rules requiring testing or enforcement on anything. So ODNR reports filter socks that are being thrown into dumpsters or burned or whatever, no way to track. And there's nothing they can do about it because they've got no rules to enforce. So we test nothing. This is all very deliberate. So where does this waste get disposed of? Solids and semi-solids go into sanitary and construction and demolition debris landfills, not low-level radioactive landfills where they ought to. There's no testing required on the solids and semi-solids. You are forbidden by law in the 2013 budget bill to even keep records of what you're putting in. There are dozens, 40-some now, I think, midstream modifiers of the waste. They're basically unregulated. There's no rules written for them, and they talk about beneficial use. We really don't know what's happening on those at all. Liquids at the Class 2 injection wells, there are more than 200. The oldest one is 1960, and there are no updates required. So what was required in 1960 when that well became an injection well is all it ever has had to live up to. Okay? That's 56 years old. And there's no testing required on any of the brines or the production water or the fracking fluid or anything. And most years, more of it is from out of state than in state. Last year, we had almost 29 million barrels injected. That's 42 gallons a barrel. It's a lot of stuff, and it's going down holes in the ground, and no one knows where it's going. So what could possibly go wrong with this idea? Well, we had had problems before 2014. We'd had people killed, we'd had earthquakes, we'd had some other things going on. But 2014, Ohio finally had enough infrastructure, enough wells, enough pipelines, enough other things to really hit the big time in terms of accidents. And here's what went wrong in 2014. Earthquakes. Dr. Ray Beersdorfer from Youngstown State Geology Department has been keeping a record of earthquakes. This is last year's data, so it's been updated since then. As of last year, ODNR had said we had 18 earthquakes. Ray looked at the data from the various groups that were studying at universities, USGS. He had 1,045 at that point. Big difference between 18 and 1,045. And that doesn't count the ones that have happened since then. And the other thing you need to know is that if you have natural earthquakes, you have the big bang, and then it gets less and less and less and less and less. With induced earthquakes, it starts out little, bigger, big. So the more earthquakes you have at a site, the higher the potential for yet even a bigger one. And most insurance companies do not cover, if you have an earthquake rider, and most people don't, do not cover man-made earthquakes if you have damages on your property. May 4th, Morgan County, there was a well leak. 7 people were evacuated. The shale well leaks during the drilling process forcing evacuation. There were 75 to 100 people involved in the cleanup, over 100 barrels of drilling mud of who knows what. Wet, raw gas and oil flooded the pad and into the creek. Okay, that was kind of the first big one. June 25th, poor Monroe County, which got beaten to pieces in 2014, had a well blowout. And then on December 13th, they had another one. And on December 13th, they had to evacuate 1.5 miles radius for 10 days. Now, that white stuff you see going up, the difference between that and a 400 to 500 foot in the air fireball is 1 spark, because that's raw methane. This is farming country. The farmers went back in every day to take care of their stock at potentially a risk to their lives. October 28th, Jefferson County has a well blowout. 400 families are evacuated at that point. It's a 2-mile radius, and it's near the Mingo Junction Sportsman's Club in Bloomingdale, Ohio. So that's 400 families. But the one that was the coup de grace was the Monroe County Eisenberg Statco well, I'm not going to call it fire, fiasco. US EPA had told DNR in 2013, I believe, am I right, Teresa, that they had to instruct the oil and gas industries that they had to report to CERC, to the local environmental protection agencies, and to the first responders. They didn't get a Hail Mary pass, they did have to report. So before the June 28th blow-up, Statsco had told them that they had production water and condensate on site. That's it. That was the weekend that Halliburton came in to frack the wells. The explosion burned for 5 days. There were 14 volunteer fire departments from 3 counties and West Virginia, and 2 county emergency management departments on the site. There were 2 30,000 gallons of propane tanks that nobody reported anywhere. There was about 50,000 gallons of chemicals for fracking on the site. There were MSDS sheets, material safety data sheets, in the trailer that said what was there, but of course the trailer was on fire. And so there was no verification from Halliburton for what was burning for at least 5 hours. No one knew what was going up in smoke. There were unsecured explosives that kept detonating and just blowing up randomly on the site. There were 3 cesium gamma loggers that were loose on the site. There was a flowing fracked well. And for 5 days it burned, and I have no idea how hot it got, but wait till you see what was left. This was the fire. It was huge. This is the aftermath. If you look on, it'll be your right-hand side, you'll see in the top picture, 2 red tractors. The lower picture, you see what was left of them. You see a hydrochloric acid tank. You see a melted shell. You see the aluminum tanker. You see a melted shell. The fracking chemical totes are completely burned away. The fracturing pumps, all 16 of them, are just pretty much ash. This was a really hot, long fire. All life in Possum Creek down to the Ohio River was killed. About 70,000 fish and everything else living in the creek got wiped out. U.S. and Ohio EPA finally got a list of the trade secrets chemicals at the site 5 days after the fire started. 5 days after. DNR had them 2 days after, but they didn't think it was important to share. And the public water intake on the Ohio River at New Martinsville, West Virginia, 1.7 miles down from the mouth of Possum Creek, never were notified that there was a plume coming down to them. The plume was days past by the time we had a full list of chemicals. The typical procedure in West Virginia is to shut the intake down. West Virginia would have told them to shut the intake down, but nobody told West Virginia. And once we finally got the list, we didn't even have tests for some of these things. So there was no way to even test to see if it was in the water or if you had tested. By the end of August, the Columbus Dispatch was saying the fracking fire points out failings. I think this is one of the most unmitigated disasters I think I've ever seen. You would think this would have woke people up and decided to make things better. Oh, no. September 24th, we've got an emissions violations in Carroll County at a compressing station. In October of 2014, Monroe County again, a brand new 8-inch Blue Racer midstream pipeline blows. And it burns until they can put it out. October the 19th, Guernsey County, we've got a well pad explosion, 1 injured. November the 12th, Noble County, another Blue Racer midstream condensate pumping skid explosion, 1 dead. We've evacuated people, we've had horrific accidents, we've killed people, we've injured people, and we've exposed people. In 2014, it didn't stop. The legislature did not come together, the governor did not come together and say, boy, we got to take care of the people of Ohio. It did not happen. The one thing that I fully expected to do was to lose a water supply. We didn't lose one in 2014. We didn't lose it until this year. And 2016, the reservoir number 1 for Barnesville gets shut down because of a tanker spill. Now, I know I've driven a lot of back roads. I know I've seen a lot of water supplies, but what are the odds that I actually knew this reservoir? I actually knew a lot about Barnesville. I actually had driven this road, so I knew exactly where this accident happened. I spent about an hour and a half last Wednesday on the phone with the ER guys at emergency response guys at EPA, and so what I'm going to show you is really a summary of what they had to share with me. It actually was about 4,300 gallons that was released. Drilling wastewater fluid, thousands of gallons. Wait a minute, let me go back here. No, that's all right. Thousands of gallons went into the creek and contaminated one of the 3 Barnesville reservoirs. The Columbus Dispatch tells us about it on the 9th. They have an announcement. It happens at 3 o'clock in the morning, and the truck overturns on the curve. Now, this is a designated Ohio EPA source water protection area. You see the circle around it. That is in the area that is considered the emergency management, well, no, it's the corridor management zone, okay? This is really serious. If this was a well field, you might call it the 1-year time of travel, but it's a whole lot faster than 1-year time of travel. So, why was the truck there at 3 in the morning? What was in the truck? And what got dumped into the reservoir? Well, the source of the brine was the Gulfport Energy's Roth well down in Monroe County. And it had been up and running for about a year, so it probably really was production water by this point. Brine trucks often travel at night, and State Route 800 is very hilly and very curvy, even during daylight and good weather. I wouldn't want to drive it in the middle of the night. So they never did explain why they were there. EPA asked Gulfport for their material safety data sheet, and they produced this paper from Oklahoma dated 5/1/15 and said it was produced water sweet. It had water, 80 to 90%, sodium chloride less than 16%, calcium chloride less than 16%, crude oil less than 1%, benzene less than 1%. They didn't mention there were heavy metals. They didn't mention there were radioactive metals. They didn't talk about contamination from drilling muds, if there was any. They didn't talk about contamination from fracking chemicals, or if there was any, because they didn't tell us where it came from. We had to find that out later. EPA decided that they were going to test for everything they could think of, which was smart on their part. They tested for radium-226 and 228, for gross alpha, gross beta, combined radium. This is a public water supply reservoir. VOCs, semi-volatile organics, total dissolved solids, metals, and phthalates, which are plastic softeners. Noon of the day of the spill, they had 3.2 picocuries per liter of radium in the reservoir. Now, that's not 5, but that's a whole lot higher than background. However, they used the US EPA 900 method to do the test. And as Greg Pace said, I well know, after a year and a half of study, that was not the right kind of test to use. And in the case of brine, it may only get you 1% of what you've actually got. So the level in the reservoir was somewhere between 320 picocuries per liter and 3.2 picocuries per liter. The more water and the less brine, the closer to the 3.2. But I'm not going to tell you it was 3.2. Barnesville number 1 reservoir has 24.7 acres in the area. It holds 140 million gallons of water. The truck only held 5,000 gallons. 1 acre-foot holds 325,851 gallons, or about 65 full tankers per acre-foot. So the good news is this was not a well field. The good news was that this was a reservoir. And you've got a better chance of dilution and flushing. Gulfport finally showed up to clean up the site 2 days later. There was spills on the southwest side where there was no spill protection. The soils there are the Westmoreland Lowell, Morristown Association. These are relatively fine-grained regolith soils. They are probably fractured, which makes secondary porosity the way that the brine would move through. And bedrock's at 50 inches, and it's fractured too. You don't get out there until 2 days later with a little bobcat to clean it up. By then, there were no standing liquids. It's either all gone into the stream or it's recharged the bedrock. And that bedrock provides base flow for the reservoir. There had been an installation of a spill collector on the northeast side of the curve, just in case something like this would happen, because EPA was expecting something like this. But the property owner on the other side chose not to cooperate, so there was no spill collector on that side. She hopefully will change her mind and let them put one in. When you look at the drinking water source assessment for the village of Barnesville that Ohio EPA did in 2003, for protective strategies, I quote, transportation routes, there is a potential for spills along roads within the protection area. Barnesville may want to consider contacting the local fire department and local emergency planning agency about the location of the drinking water source protection area so that strategies can be developed to prevent spilled materials from impacting the village's reservoirs. Oil and gas production. The village could meet with well or landowners to discuss the status of the wells or issues of concern such as proper equipment operation and maintenance and well abandonment. In 2003, there were old oil and gas wells within the source water protection areas. But this, of course, is long before fracking. Such meetings can also be used to develop an early warning system for accidental spills and releases. Currently, the law in Ohio says that a drilling pad has to be 50 feet back from the edge of the water. Barnesville had an agreement with the drilling companies that had the mineral rights under their reservoirs for a 500-foot setback. It's a whole lot better than 50. But the Ohio EPA corridor management zones are 1,000 feet. So that puts potential drilling pads halfway down the hills. And if we lose one of those wells for whatever reason that we've seen, that's a potential impact for the reservoir all over again. And these are the two biggest reservoirs. Ohio EPA emergency response thought last Wednesday that the report would be completed by Friday. I don't know whether it was done or not. And Leah, have you heard anything? We're still waiting. So they were waiting on some chemistry, and they didn't know when they'd get it. They said that once they released it, this reservoir went off March 9th. It is now May 17th. It is still offline. Once they released it, then there was going to be rigorous testing protocol that was going to be developed by the Division of Drinking and Groundwater before the reservoir could come back online, because they didn't want it back online until they were sure that the reservoir was truly flushed and truly safe. Barnesville has 3 reservoirs. They are the regional suppliers to parts of 4 counties. There are no interconnections to any other source. And you're looking at tens to hundreds of millions of dollars to replace public water supplies if they are taken out. And there is no state or federal money to do it with. and there is no bonding or insurance with the industries to cover those costs. So those become local costs. So we don't know when or where the next accident will happen. We haven't had a bomb train yet, but you know, the one that went off in West Virginia in 2015 came right through the center of Columbus, right through West Campus at Ohio State before it blew up in West Virginia. We don't know what kind of accidents it's going to be. We don't know the type of accident, but we do know the type of accidents that happened in 2014. We know the kinds of things and what's happened this year. We know the kinds of things that have happened here in Ohio. Statistically, we know it's going to happen again. Maybe the next time it's in your neighborhood. So you have to have a plan and you have to be prepared. But you should also ask your state reps and senators to pass legislation to protect Ohio and its people instead of the oil and gas industry. We are protecting the oil and gas industry. We are not protecting Ohio's people. So here are some contacts. Mine and Dr. Ann Christie and Linda Aller at Bennett and Williams, and we're kind of the core of the Ohio Fracture Flow Working Group. And when we say fracture flow, we're looking at fractures in soils and glacial materials. Fractures in shale are, you know, kind of the same thing. And this is the link to EPA's Division of Drinking and Groundwater. So with that, I end. I hope I'm on time, and I'll take any questions if anybody's got any. Yes?
Test results, and after over a month, the village council couldn't answer any questions. We hadn't had any test results back from the EPA.
Well, I don't know who at EPA said that. The person I talked to clearly knew that was not the case.
There were two different people that had actually called the EPA, and they both said the same thing, that it was just brine water, there was no need to worry, and that the test results weren't
They wouldn't
expedited.
have run all those tests if they hadn't known what was in it.
Right, but they told the public, you know.
I can't address that. I didn't get told that when I talked to them.
Well, they know you know better, and they're assuming that we don't.
That's very possible, but I'm waiting to see what the report looks like because they ran the wrong tests, so their numbers are going to be biased low. I don't know how badly they're biased low, but they did take samples straight out of the truck. Those will be badly low, and like maybe 1%. And they also took sediment samples, and you can't run those that way either. So those won't be anywhere near accurate.
One other thing I'd like to mention about this situation is that it had been maybe even 6 weeks, and no test results had been given back. And so I went to a village council meeting and gave them some information about what brine consisted of, and requested that they contact the EPA or do their own testing from that point on to try to determine what was happened. And anyway, within a day, they had the EPA out there and they took action, but it took, you know, our group.
Well, but I'm not going to tell you that Barnesville is faultless, because when this happened, I got a hold of my friend Tyler Converse, who is the superintendent of public water in Canton, and very, very active on the state level of the Ohio American Water Works Association, and all the public water supply people are talking about this. And Tyler's words were, they didn't tell me what was in it, they didn't tell me what they tested for, I'd have been on CNN. Why weren't your village people on CNN?
Exactly.
That is their fault and their mistake. There are things they could have done and did not do for whatever reason. Okay, that's their fault. Yeah.
That oil and gas company was not liable for that accident?
Well,
Insurance-wise
they were liable,
Yeah.
okay? But to what extent? To whatever their insurance riders were. And it wasn't it was Gulfport's brine, but it wasn't Gulfport's truck. So whatever the trucking company had in liability is what it was. If this had been a well field, where you don't get flushed through like that, where it takes years and decades and hundreds of years to clear through, and it had taken out part of a well field, or if it had been a small well field, you would have had to have found a complete new source. And then you're talking tens to hundreds of millions of dollars. There's just no money to fix it.
Yeah.
And at any given time, somebody in Ohio has either lost a water supply, are fighting to hold on to one, are trying to clean one up, or are looking for a new one because they lost one.
So it sounds as though the liability around these companies and these issues is a big black.
Oh, the liability is like nothing. It's like drops of, it's nothing. It comes nowhere near. It means that the local people foot the bill.
Again, unbelievable. Next quick question. Is these protected watersheds, of course, is there not a violation in driving something like that through this? And what happened with that?
The answer to that is no. And I'll tell you why. Because it's not hazardous. If it was labeled hazardous, we would have the ability to say you can't drive through the source water protection area. If you're hauling hazardous materials to Columbus, if you're coming downtown, you can come downtown with it. Otherwise, you have to drive the outer belt. You're not allowed to bring it downtown. So we have to get Ohio, and it's an easy thing to do. Practically, politically, it's probably impossible. But what we have to do is get the Ohio House and Senate to declare materials that are clearly hazardous by chemistry a hazardous waste, and therefore responsible for tracking from cradle to grave, and therefore for public water supply source water protection areas, we can tell them they have to drive around. How is that a big deal?
Your presentation dealt primarily with potential surface contamination due to transportation, leakage, and improper disposal, as if there is a proper method of disposing of some of these wastes. But I have a question about subterranean contamination. I went to an ODNR, Ohio Department of Natural Resources, open house function near Athens a couple of years ago, where I spoke with one of the well inspectors who presumably has a background in geology. And I asked about the possibility of subterranean migration of pressurized fracking fluids and other contaminants that are used in the process. And he told me that it was virtually impossible for that to happen. And that even if it did happen, it would happen at such a low depth that the water tables that we rely on for drinking water and agriculture would never be at risk. However, I spoke with a well inspector who said that not only is that kind of subterranean migration possible, it's also anticipated, and they currently take advantage of it when they uncap, abandon, or close wells that are in the vicinity of new wells in order to extract the pressurized fluids from those old abandoned wells that are thousands of feet away from the new wells. So
now, the reason I didn't talk about it is they only gave me 40 minutes. I mean, if you want to talk for a week, I could do that. All right, here's the deal. We have almost 300,000 oil and gas wells in Ohio since 1860. 150,000 of those, we have no idea where they even are, okay? They predate anybody's records. Some of them we kind of know because they're still leaking and bubbling oil and gas at the surface. But Rockefeller started the Lima-Findlay Arch and the fields then. And that, I mean, we were drilling from the first well went in 1860 in Marietta. So half of these we don't even know where they are. 60, not quite 65,000 are in production. So that minus 150,000 are the ones that we kind of know where they are maybe, and maybe they got abandoned and maybe they didn't. And of course, most of these formations were already drilled, especially for the injection wells, were already drilled for oil and gas. See, these old injection wells are old oil and gas wells. So what happens once it goes down there, nobody really knows. Because many of these were never properly, maybe they got a cap at the top, maybe they don't. Maybe we know where they are, maybe we don't. But you've got a potential hole all the way up to the surface. On top of that, in the coal mining areas, 40 to 60% of those counties are hollow underground from all of the coal mining. And the oil and gas wells go right through the old mines. So you can have it coming up a half dozen old oil and gas wells into old mine workings and never see it at the surface. But more times than we want to count, those flooded old mines are also public and private water supplies. So it's a serious issue. Well, you have to remember one of the reasons we don't know where a lot of these are is because during World War I and World War II, they pulled the old casings for the metal drives. And so maybe they put rocks in the top, maybe they put it in a black locust fence post that lasts about 100 years. So you can't find them with a metal detector. What they're doing in Pennsylvania, and this is brilliant, and I wish we would do it here, is they're doing them with methane snifters. And they're going out and they're walking the fields and the woods, just back and forth and back and forth and back and forth with methane sniffers, and they're finding them. Yes?
Have a connection with the water, possibly. They are injecting into the mines in Bell Valley, Ohio, right into those mines that go right underneath the drinking water in Noble County.
Yep. I expect there's going to be all kinds of crises. I mean, I'm going to be really surprised if we don't have a whole lot more fiascos. You set up situations where it can't possibly not fail, and then you can't be surprised when it does. I mean, there's a point at which statistics just tell you it's going to happen. Yeah, and as long as that works, we're okay. As long as dilution works, it's okay. But the point comes when dilution doesn't, and that's how we lose public water supplies. That's how you've got Little Hocking with more C8 in their well field than any other water source in the entire world. That's how we almost lost the well field at Springfield because of a pad of road salt. We lose water supplies. We lost Camden's because of road salt. We lose water supplies because we overcharge what can be diluted. We cannot be surprised when dilution fails. We can't.
Julie,
I gotta go. I'm getting long.
We could go on, and we need to hear more from. Thank you, Dr. Rice.